The word science comes from scientia, the Latin word meaning knowledge. Unfortunately, knowledge can be quite elusive. If you detach an apple from a tree, you know what's going to happen. It falls. No problem here. That's sound scientific evidence. However, what if you spray those apple trees with a pesticide and then eat the apple that you pick from that tree and ask the question, what is the effect of that on us? We have those pesticide-laden apples. The question is, what happens if we eat them? That's a completely different kind of question from the apple falling from the tree, because we don't have a simple answer here. This is a very complicated business. Some activist groups will tell us that there are up to 36 different pesticides that can be found on that apple, and they scare people away from eating apples. Well, the fact is that there are 36 that are registered for use. No farmer would ever use 36. And of course, they never talk about numbers, which is critical to science. Nor do they mention the fact that apples contain acetone and formaldehyde naturally occurring in higher concentration than any pesticide residue. So our knowledge has to revolve around numbers. That's what makes science function. So to suggest that apples are toxic because they may have pesticide residues, well, there's no evidence for that. That's junk science. So we better define what that is. Any kind of argument that claims to have greater evidence than what is really available, that is really junk science. We rely not on such junk science, we rely on the peer-reviewed literature. Of course, this is pretty complex as well, because not everything in the peer-reviewed literature is sound. We know that Andrew Wakefield's fraudulent paper about vaccination was published in The Lancet, one of the prime peer-reviewed journals in the world. So we never set store by one single publication. That's just one piece of the puzzle. Science is all about putting all the pieces of the puzzle together, see what the consensus opinion is before we make any big decision. The peer-reviewed literature is fascinating to examine, but there are various kind of qualifiers that we have to introduce. For example, we cannot always rely on high-dose animal studies, and yet that's what the lay public gets from the media, because there are many studies done on animals, and of course, by the time it gets interpreted for the public, it seems that the evidence is for humans, which of course it isn't. And furthermore, even if you look at animal studies, animals behave very, very differently exposed to the same substance. For example, dioxin, very often talked about as the most toxic substance ever made. It's never made on purpose, of course, it's always the byproduct of some process. And it is very toxic if you happen to be a guinea pig. But if you're a hamster, you can practically frolic in it. So even in those closely related animals, you have these very, very different degrees of potential toxicity. One of the biggest mistakes that is made, especially by the media as they interpret science for the public, is to label anything that is synthetic as somehow more dangerous than something that is natural. In my close to 40 years of being in this business, this is the biggest myth I have to fight. Of course, nature is not benign. Nature is very dangerous. Bacteria, fungi are nasty things. We spend a lot of our life trying to outwit nature. It doesn't matter if a chemical was made by Mother Nature in a bush or by a chemist in a lab. What matters is what it is and how much we know about it. A small risk can be doubled, but it still remains a small risk. You know that there's a risk if you go out and you get, in a storm, the risk of lightning. If you go out into that storm with an umbrella, you have doubled that risk. But of course, the risk is still trivial, not even worth worrying about. But it could be presented as a 100% increase in risk. And of course, this is very often what is done by the media. The presence of a chemical does not equal the presence of a risk. Chemicals are not toxins. Chemicals are things. They are the building blocks of all matter. It makes no sense to talk about chemicals without putting them into proper context. There are some chemicals, of course, which can be problematic in very small doses, but the dose always matters. Paracelsus, 500 years ago, of course, laid the cornerstone of toxicology with his classic dictum, sola dosis facit venenum, only the dose makes the poison. There, of course, are opposing views on how we interpret science. And there's a lot of clamoring. And journalists go out, interview both sides, and write an article often suggesting that the two sides have equal weight. We see this in global warming all the time. The two sides don't have equal weight. One side is based upon the work of thousands and thousands of researchers. The other side may be a few rogue scientists. And of course, we see this in the area of cosmetics all the time, where you have some outspoken scientists with legitimate backgrounds who make all kinds of statements, but of course they are outweighed by the massive opinion on the other side. But that never gets heard. Journalists are trained to interview one, interview the other, and write, quote, a balanced article. Well, the balance usually is not there. There are no safe or dangerous substances. There are only safe or dangerous ways to use them. As we drive down the highway of life, we do have to prepare to pay the tolls. There are risks out there and there are hazards. The two are not the same. And Dr. Flower will now take over and tell you the significant difference between risk and hazard.
Good morning, ladies and gentlemen, and thank you very much for the opportunity to be here. Risk or hazard, you've heard the words. Surely simply dangerous, don't they not mean that? Are they not the same thing? Well, I hope that by the end of my very brief talk, you will understand a little better the difference between risk and hazard and the importance of keeping that in mind. As we've heard, everything is chemical. Everything in the known universe is chemical. One of my favourite books is Alice Through the Looking Glass by Lewis Carroll. And in one particular chapter, Alice is talking to the White Queen. And the White Queen says, for instance now, there's the king's messenger. He's in prison, being punished. The trial doesn't begin until next Wednesday. And of course, the crime comes last of all. Suppose he never commits the crime, said Alice. That would be better, wouldn't it, said the Queen. Well, Alice felt there was no denying that. Of course it would be all the better, she said. But it wouldn't be all the better for him because he'd been punished. Well, you're wrong there, said the Queen. Weren't you ever punished? Well, only for faults, said Alice. And you were all the better for it. I know, said the Queen triumphantly. Yes, but then I had done the things I was being punished for, said Alice. That makes all the difference. But if you hadn't done them, said the Queen, that would have been better still. Better and better and better. And Alice was just beginning to say there's a mistake here somewhere when the Queen began screaming so loud that she had to leave the sentence unfinished. Well, there are plenty of people out there screaming loudly, punish chemicals, because they might commit a crime. And what would that punishment be? Prohibition, restriction, and indeed, I think that the precautionary principle has been perverted to say, if you can't prove that that substance is safe, you can't use it. Their thinking seems to be, I don't like that chemical, so you can't have it. But as we've heard, it's based largely on emotion and not evidence. It's not based on science. You need to ask for the facts and data. But are there any innocent chemicals out there? We toxicologists sometimes make jokes, and one of our favourites is that the only safe chemical is the one we haven't tested enough yet. Because sooner or later you will find something wrong with everything. Water, drink 5 litres of it, there is a very real risk you might not wake up in the morning. This wool killed thousands of people 200 years ago in the mills because they inhaled tiny little fibres from it. and developed a disease called byssinosis. Most of the mill workers died when they were about 35. There were very few that lasted till their 40s. So even natural stuff like wool can be very dangerous. Sooner or later, everything has dangerous properties, and that's the hazard, the intrinsic dangerous nature of the substance. What are the chances of meeting those dangerous properties? That is the risk. It depends on exposure. We can all imagine the hazard that a hungry lion represents, but the risk to you depends on your exposure. If the lion is safely caged, your exposure is zero. No matter how hungry the lion, you have no risk. Put yourself inside the cage with the hungry lion. The hazard remains unchanged. Your exposure has gone up dramatically, and the risk has gone up accordingly. So we're talking about exposure and risk. The final slide, which I translated into Canadian, comes from Mr. Micawber in David Copperfield by Charles Dickens. And he says, annual income $20, annual expenditure $19.50, result happiness. Annual income $20, annual expenditure $20.50, result misery. We translate that into toxicologist speak. Exposure below the toxic dose, result happiness. Exposure above the toxic dose, result misery. It's all down to exposure. Thank you very much.
I'll be talking about products, ingredients, and sound science. How all of these principles really apply in cosmetic and personal care products. What are the essential things about preservatives? They are added to products to prevent growth of microorganisms. They have inherent hazard. Preservatives are added to kill microorganisms. They can be toxic. However, in the way that they are used, they are safe. And the way that they are used is in a way that balances and mitigates their potential risk. Preservatives can be natural compounds, they can be organic, they can be synthetic. You can preserve a product not just through preservatives, you can preserve it through the container it's in, the packaging it's in. If you have single-use cosmetics or single-use products, they can be adequately preserved. The type of use of the product and the type of product has a great impact on the preservation and the type of preservatives you use. Lipstick, you don't need preservatives. There's no water in lipstick. Microorganisms don't grow. However, you need preservation in a shampoo that sits in a shower, a hot, humid shower, day after, I won't even go there. So when research and development folks develop a product, they consider the safe level of the preservative as well as the effective level of the preservative. And they balance that so that the end product is effective enough to kill and prevent microorganism growth and yet not harm the patient, not harm the consumer in any way.